Hello guys, it's Johnny time and welcome to another smart contract hacking tutorial. Today we are going to solve the 10th challenge in DEM Vulnerable DeFi version 3, which is the free rider. This is going to be super cool challenge with NFTs, flash swaps and many more cool things. So without further ado, let's get started. So this is Free Rider, and a new marketplace of damn valuable NFTs has been released. There has been an initial mint of 6 NFTs which are available for sale in the marketplace, each one at 15 ETH. This is very expensive, guys. 15 ETH, considering ETH is $2,000. This is a lot of money for NFT. The developers behind it have been notified that the marketplace is vulnerable. All tokens can be taken, yet they have absolutely no idea how to do it. So they are offering a bounty of 45 ETH of whoever is willing to take the NFTs out and send them their way. You agree to help, although you only have 0.1 ETH in balance. The devs just won't reply to your messages asking for more ETH. If only you could get free ETH at least for an instant. So we have here a marketplace that probably has a vulnerability. They sell NFT with crazy prices, exactly 6 NFTs, and the devs knows that there is a vulnerability. They don't know what is the vulnerabilities. That's why they made this bounty for 45 ETH, which is a very nice bounty. And somehow with 0.1 ETH, you should steal those NFTs from the marketplace and send the devs those NFTs. Now let's head over to the contracts and see what we have. So we have 2 smart contracts, Free Rider NFT Marketplace and Free Rider Recovery. This is the marketplace contract that should have the vulnerability, and this is the contract that is responsible for the bounty. So once it receives the NFTs, it sends automatically this price, 45 Ether. Now let's get to the marketplace and see if we can find some kind of vulnerabilities here. So it's protected by Reentry Guard. Well, we have the token, the NFT, the offers count, probably the amount of NFTs that are being offered in the marketplace, and a mapping between token ID to its price offers. We have 2 events that we emit and around 8 errors. So we can raise those errors once we have validation issues or some unexpected behaviors. We can revert with those errors. Now, the constructor receives an amount, then it deploys the new NFT token, re-announce ownership, so the token don't have an owner, no one can mint it, no one can burn it, only this constructor can do that. And as you can see, we mint those NFTs. So we iterate from 0 to the amount, then we call the safe mint function to mint those NFT to the message sender, which is the account, the EO account that deployed this smart contract. And we just do this loop to mint those probably 6 NFTs, depends what amount is being sent to the constructor, and we set a token state variable. Now we have here some functions: offer many, offer one, buy many, and buy one, and the contract can receive ETH through this receive function. So offer many is a function that receives an array of token IDs, an array of prices. It makes sure that the length is not 0, so there is at least one item in the array, that the array length is same for both arrays, and then what it just do, it's just gonna call the offer one function, internal function, private function, and this function, let's see what it does. It basically checks the token, gets the token ID and the price, make sure that the price is not 0, make sure that the message sender, the one who is offering the tokens for sale, is the owner or he is approved. Okay, so if message sender is not the owner, then it's not approved, then it will revert the transaction, and it makes sure that it approved this smart contract to spend these tokens, because if it didn't, we won't be able to use the transfer from function later on, probably to sell those tokens to someone that wants to buy it. Then it updates the mapping of the token ID and the price, do some kind of gas saving, whatever, assembly YUL code, and emits an event that a new NFT was added to the marketplace. Now we have this buy many function that allows users to buy NFTs. It's a payable function, so you need to send ETH in order to buy those NFTs. You pass an array of token IDs, then we iterate and call the buy one function. This is a private function, and we take the price to pay from the offers mapping, and we make sure that it's not zero, because it's zero. If it's zero, it means that the token ID does not exist and it's not offered, because by default the mapping uint value is zero. Then we make sure that the message value is greater or equal the price to pay. Okay, if you try to send less ETH for this particular token, then it will revert with insufficient payment. Then it reduces the offer counts, reduce the amount of NFTs that are being offered in the marketplace. It transfer the token, use the safe transfer form to transfer the token from the owner to the message sender. So the NFTs are never being kept in the marketplace itself, but we just, in the offer one, we approve the contract to spend it, and in the buy one, we transfer them directly from the owner of the NFT to the message sender, to the one who buys them. Then we're gonna send the value to the owner of the NFT using the send value function from the address library. We're gonna send the price from the message sender to the owner of the NFT, and we emit an event. So we went through the whole code, and now I want you to stop for a second and try to look, especially in this buy one function, and see if you can find and spot some logical vulnerabilities that exist in this function or in general in the smart contract. So pause the video for a second, try to look at it in your machine, in your local computer, and try to see what you're able to detect. All right, guys, so this has, in my opinion, three main issues. The main critical issue here is first this one. Okay, what are we doing here? We are transferring the token from the owner to the message sender, from the seller basically to the buyer. And then we are sending the value, sending the ETH, not to the new owner of the token. Now the buyer is already the new owner of the token, which means that the seller does not get any ETH. So this is the main critical vulnerability in this buy one function. I know it takes a while to see it and understand it, because it's pretty creative, critical vulnerability, logical vulnerability. And as you can see, we transfer the token first, which means that the token change ownership, and then only we transfer the ETH to the owner, which is already the new owner, which is the buyer. So we're simply just refunding the money to the buyer without sending it to the seller. The money should be sent to the seller, to the previous owner of the NFT. This owner is going to be changed because we use the transfer function. So this is the first logical critical issue that I can see over here. And by the way, if you find it a bit challenging to review code, to find those issues, and you feel that you need a stronger foundation in smart contract security and hacking, definitely check out the complete practical smart contract hacking course. Imagine a course that takes you from complete beginner level to intermediate advanced through practical exercises and awesome lectures. So you're gonna learn everything from Oracle manipulations, ERC 721 vulnerabilities, re-entry attacks, replay attacks, and so much more through lectures. And then we will have exercises like this one, which you're gonna solve in your local machine. And then you have a walkthrough with me to show you how I solve and how I approach the problem and the challenge. And another cool thing that you're gonna get is access to an exclusive closed community with other students, so you can embark on the journey together and meet new people, ask questions, mingle with people in the space. And of course, there will be also a final exam and official certification that comes with a lot of perks and is being acknowledged by a lot of big Web3 companies in the space. So it can definitely help you to land your first smart contract security researcher job. If you're interested, check out the link in the description below for a special limited time discount. So this was the first critical issue. Another critical issue that this function has that I found is that, let's try to think about it. When you call the buy many function, you send ETH, and then it's gonna iterate through every token. And what it's gonna do, it's basically gonna make sure that the message value is not lower than the price to pay, which means that you can pay only for one token because the message value is the same. Even though we send the ETH to another account, the message value in this context, in this transaction, is always gonna be the same, even though the contract sent the ETH to another account, because it's the same message value, it's the same transaction and same message, which means that you can basically pass a list of 6 token IDs and pay only for the most expensive one. So if you have 6 token IDs, one is priced, all of them are priced in 15 ETH. So you don't need to pay 15 multiplied by 6, but you can pay only 15 ETH for all the 6 token IDs. This is another critical vulnerability. And you know what? I want to write it over here, audit issue. This is how I work. When I audit smart contracts, I always add these audit comments that help me to understand the code and write the issues. And I can purchase 6 NFTs while paying only for one, since message.value does not. Let's make another line. This will be here, audit info, message.value doesn't change even if we send the ETH out. So this is very important to understand. And this is another critical vulnerability. And this critical vulnerability audit issue, let's write it down. There is another audit issue that basically ETH is being sent to the buyer instead of the seller, and we will add here another audit info, and we will write this happens because we transferred the token before sending the ETH and changed its ownership, right? So these are the 2 critical issues that I see over here. There is another critical issue that is actually basically so since the NFTs are not being held in a smart contract, and this will work only if the approval exists, right? Now we approved here in offer 1 the contract to spend the token, but what if between the offer 1 to the buy 1, the owner of the token is removing the approval? It also can happen. So we can call the offer many and basically approve all the NFTs for the smart contract, right? It basically adds the approval and then it changes the mapping that we have new offers in the NFT. But then after it calls the offer many, right after it's gonna withdraw the approval from the smart contract and don't allow it to spend this particular token IDs. So when someone is trying to buy them, this will fail because safe transfer form will fail because the approval will be revoked and it will basically create some kind of denial of service. The contract will think that the token is listed while the seller actually revoked the approval. This is another issue. I would call it a medium issue. And here I can just edit audit issue. I'm not sure it's going to help us with the exploitation of this smart contract, but it's another issue that if it would be an audit contest or a smart contract audit that I do for clients, I would report that this is a medium/high issue. Seller can revoke the approval, revoke the token spending approval. So this is another medium/high issue that I would report, but now we need to think how we can exploit this smart contract. So assuming we can call this function by many, and we can pass a list of all the 6 token IDs because we need to retrieve all the 6 token IDs. We need to pay only 15 ETH. We don't need to pay 15 multiplied by 6, which is 90. So we don't need to pay 90? No, not yes, 90 ETH. We don't need to pay 19 ETH. We need to pay 15 ETH only. But the problem is that we don't have 15 ETH. We have only 0.1 ETH. Even though we're going to get back the 15 ETH since of the second critical vulnerability, it doesn't matter because we need somehow to get this ETH. And we got hints over here. if only you could get free ETH at least for an instant, right? And we get another hint over here. If we look at the setup of the smart contract, we see that they deploy Uniswap factory and router together with a wrapped ETH and another token, and they add some liquidity with ETH. So they add liquidity of the token with ETH. So they deploy some kind of Uniswap pool for us with some ETH. And we can see here the constants that we have: initial token, initial wrapped ETH. We have 9,000 ETH and 15K tokens in this liquidity pool. And maybe we can utilize this Uniswap liquidity pool in order to get those ETH. Now, how are you gonna do that? Before we figure out how we get ETH, let's see how the recovery works and how we can basically receive the prize once we steal those NFTs. So this is the contract. We have the hard-coded prize, the beneficiary who is going to receive the prize, the token address, and received some kind of uint private received. We have some errors, and this is the constructor. So upon construction, we send the beneficiary and the NFT, right? And we make sure that the message value is the price. So we send enough ETH, we set the NFT, and we set approval for all to message sender. So we basically approve the message sender to get all the NFTs of this smart contract, of this particular NFT smart contract. So if we go to the scripts, we can see that we are the beneficiary. So we could be the ones that rescue the money, the funds. The player address is the beneficiary. We can see the bounty. We can see the NFT address. So you can take a look at all the setup and all the deployment. We won't get into that. We need here to execute our code, and eventually we need to make sure that all the NFTs are extracted, and the dev's EOA address is the owner of all the token IDs from 0 to 6 to 5. Then we're going to make sure that there are no offers in the marketplace, there are 0, and that the marketplace balance is less than the marketplace initial ETH balance. So it doesn't have any balance, basically. And eventually we're supposed to earn all the ETH. So our balance is supposed to be greater than the bounty, and the dev contract is supposed to have 0 ETH. So we're supposed to get all the ETH from this contract, and the player account, the EO account, is supposed to be all the ETH. Now, going back to our question, how do we get those 15 ETH? Now, we got some hints, if we can get it for a slight second, and the hint is basically referring to flash swaps. Uniswap allow us to do something called flash swap. It means that we can basically take all the tokens from the liquidity pool as soon as we pay them back plus fee at the end of the transaction. So eventually the pair should have more balance that it had in the beginning of the transaction, and this is called flash swaps. Now, again, if you want to deep dive deeper into flash swaps and flash loans, these are chapters that we cover in depth in the smart contract hacking course. So check out the course in the description. So you're gonna master all kinds of flash loans, flash swaps, flash loan attacks, and all these kind of cool exploits. Now let's see how we can basically execute a flash swap. So I'm just gonna search Uniswap V2 flash swaps on Google, and here you can see how flash swap work through Uniswap docs. And simply the way it works, we can just call the low-level pair function, the swap function, and pass data. The data is the data that will be passed to the callback, and we can simply just request tokens from the pair contract with this particular data, and it will make a callback for us. So it will move the execution from the pair smart contract to our external contract, and we can do our own logic, whatever we want with the tokens. We're going to receive the tokens that we want to get fresh swap from, and we do whatever we want with the tokens, and then we need to pay them back, and basically the execution will come back to the pair contract, and it will make sure that it receives more token that it basically sends in the beginning. So as you can see here, we can trigger a flash swap by sending data length that is greater than 0, some kind of data, and then we will receive this callback in our smart contract, Uniswap V2 call with all this data, and then we can do whatever we want with this data. We can do whatever we want. We just need to make sure to pay back the tokens, or it will revert the transaction. The pair contract will revert the transaction if we don't do this repayment. So I'm just gonna, before we start doing these flash swaps, now that we understand how it works, let's try to plan our attack. So in order to execute the attack, I will need to create a smart contract, because in order to utilize flash swaps, we need to have a smart contract to receive the callback, do something with it, and then bring back the funds to the Uniswap smart contract. So I will create a new contract here, attack free rider .sol. This will be our malicious contract to attack the marketplace. And let's just paste it over here and remove everything. And let's call it attack. And instead of naive receiver, free rider. And we don't need this interface. That's it. We have a template for our new malicious contract. Now let's try to plan our attack strategy. So the first thing we want to do is request a flash swap of how much ETH do we need? We need only 15 ETH, right? We don't need more, because we know that it's enough due to the vulnerability. We need only 15 ETH to get all the 6 NFTs. So 15 wrapped ETH, because we cannot request flash swap of ETH. We'll just request wrapped ETH, and then we're gonna unwrap it to native ETH. So request a flash swap of 15 ETH from Uniswap pair, right? Step 2, this is step 1. Step 2, we're gonna unwrap wrapped ETH to native ETH, right? Because we need to pay in native ETH to the marketplace. Then, guys, with this ETH that we got, we're gonna buy 6 NFTs for only 15 ETH total, right? Now, then remember, we have the second critical vulnerability, which means that the marketplace is gonna send us the money, the ETH back instead to the seller. So we will have enough ETH to pay back the flash loan, the flash swap to the Uniswap pair. So then we're gonna pay back 15 ETH, wrapped ETH. We need to basically, we need to deposit again to wrapped ETH plus 0.3% to the pair contract. So flash swaps has 0.3% fee. So we will have to pay this extra fee. So the pair contract will be happy and will not revert the transaction. And eventually we want to send all the tokens, send NFTs to recovery contract. So we can get the bounty. Awesome. We have a beautiful attack plan, and now let's start to implement it. Now, let's try to understand what do we need in order to request a flash swap from Uniswap pair. So we will need to work with the pair smart contract, and therefore I'm gonna basically import the interface of the pair smart contract. I'm also going to import the wrapped ETH interface, because we will work with wrapped ETH with deposit and withdraw wrapped ETH. We also need to work with ERC721 tokens. So I will import this from OpenZeppelin, ERC721, and the receiver, because we should receive to this smart contract NFTs. So I need to implement the receiver interface. And now that we have all our imports ready, let's think of the state variable. So the first one is the pair Uniswap pair contract that we're going to request a flash loan. So it's going to be private, and it will be immutable because it doesn't change. It's going to be the pair smart contract. Then the next one is going to be the marketplace, the exchange. We'll have to define the interface of the marketplace as well. So interface I marketplace, and it will be the interface to buy those NFTs from the marketplace. We'll need to buy them using the buy many function. So I'm going to copy the function and define here the interface, and this will be I marketplace, private, immutable, and it will be marketplace. Then we will need the address of the recovery contract, because we want to send the NFTs to this recovery contract so we can get the money later. So it will be address, private, immutable, recovery contract. We need also to define the token. So we have the wrapped ETH and the NFT. So I will do wrapped ETH, I wrapped ETH, private, immutable, and it will be just wrapped ETH. And we will have also ERC721, private, immutable, and it will be NFT. We will also define the address of the player. So let's define it here. Address, private, immutable player. because we want to send him the money eventually. Let's define also the constant of the price for the NFT. So it will be uint256 private. Let's do constant, and it will be, let's do NFT price, and it will be 15 Ether. And let's also define an array of the tokens that we will use later. So uint256 private, and it's just going to be tokens, and we have 6 tokens from 0 to 5. So 4 and 5. Awesome. We have all our state variables ready, and now it's time to create a constructor. So constructor, let's see what our constructor receives. So we need to set all these immutable variables. So we'll need to receive them in the constructor. So it will be address of the pair. It will be address of the marketplace, marketplace. It will be the address of wrapped ETH, the address of the NFT, and the address of the recovery contract. And now let's set all those state variables. So the pair equals the iUniswap pair of the address. The marketplace is going to be the iMarketplace of the marketplace address. The wrapped ETH is going to be iWrapped ETH of the wrapped ETH address. I'm just setting all the state variables. Very, very easy. The NFT IRC721 of the NFT. And the recovery contract is just going to be the address because we don't have any interface. We don't need any interface for that. And don't forget to set the player, right? Player equals message.sender, the one who deploys this contract. Awesome. Now let's start our attack function. So function attack, and it will be external. It doesn't gonna receive anything, okay? That's it. We don't need actually to receive anything here. Maybe just let's make it payable because we'll need to send some ETH extra because we are paying 15 ETH plus 0.3% fee. So we cannot just take 15 ETH from the Uniswap pair and then pay back 15 ETH. We need to pay slightly more. So we'll have to send some ETH to this attack function to cover for the fees for Uniswap. And now here we're gonna make step 1. So here we're gonna initiate the flash swap of 15 ETH from the Uniswap pair. So how we're gonna do it, we can just jump to the iUniswap pair here, and we can see just how the swap function look like. Where is the swap function? Here is the swap function. Let's just copy it. This is the function, and now we will know how to use it. So this is swap. And this is the parameters that we need to pass, right? So the amount 0 is basically the first token that we want to get the flash swap from. So we have the first token and the second token, and we need to specify how many tokens we want to receive from the per smart contract. Now we need to figure out which token is 0 and which token is 1. But let's first fix this. It will be pair dot swap, the per smart contract dot swap, and amount 0 and amount 1. Let's see what is amount 0 and amount 1. So just by going to the test file, we can see that token 0 is the wrapped ETH and token 1 is the token, which means that we need to pass amount as amount 0 because we want wrapped ETH. We are not interested in the DVT tokens. So I was just gonna post here the amount that I want. What amount do I want, guys? Just the price, right? So where is the price? NFT price. This is the amount of wrapped ETH that I want to receive from the Uniswap pair. This is just going to be 0. Address 2 is going to be just this smart contract, address this. And we need to pass some bytes, some data. We cannot just pass empty string because then it will not trigger the callback of the flash swap. So we need to define some kind of data. So I'll make bytes, memory, and data. And let's encode the NFT price, the amount that we're gonna receive. We're gonna encode it to bytes and send it here as the data. So it will be just data. Awesome. Now that we initiate the flash swap, we will receive a callback. And after this callback, we already supposed to have the wrapped ETH in our smart contract. And this is the function that we need to implement, as you can see over here. So we can just copy this function. Let's click copy. and paste it here. So this will be the function. Now let's define it. So first we're gonna make it external, and let's just remove this thing here. And I'm gonna do some access control over here. So I want to make sure that I will do a require statement. The method.sender equals sender equals the address of the per smart contract. So no one else can call it, only the Uniswap per smart contract. And I also want to make sure that the one who initiated this flash swap, the TX origin, the EOA account that initiated this flash swap is my player account, right? So this is some access control. I'm going to add here access control just to make sure that no one else is able to use this smart contract, but only us. Now, guys, we are actually not interested in all these parameters, so I can just remove them. But you know what? Let's just leave them as is, just for the sake of being. And now let's think what we need to do. After access control, we want to unwrap the wrapped ETH and receive the native ETH, right? So that's what I'm gonna do. And how we're gonna do it? Just gonna call the wrapped ETH withdraw function. So wrapped ETH.withdraw, and the amount that we want to withdraw, which is the 15 ETH. It's the same amount. We can decode it from the data. We can take it from the amount 0, or we can just use the constant variable, because it's going to be the same 15 ETH that we requested, right? So we're going to just withdraw it. But remember that in order to withdraw this ETH, you need to add a payable fallback function, receive function, or the wrapped ETH smart contract won't be able to send you the native ETH. Now we're supposed to have enough ETH in this smart contract to purchase those 6 NFTs. So I'm just going to just paste this next to do over here, buy 6 NFTs for only 15 ETH total, right? We don't need to pay any more NFTs. And in order to receive the NFTs, I also need to add this kind of on ERC721 received basically function. So because there's going to be a callback after we do safe mint over here, safe transfer, not safe mint, safe transfer form. What happens that it's going to make sure that my contract can receive those NFTs by returning this selector. And again, if you are not sure about ERC721, ERC20, we cover all of these subjects in the advanced smart contract hacking course, so make sure to check it out. So now we just need to call the buy many function with the token IDs, right? So I'm just going to do marketplace dot buy many, and I can just pass the token that I defined already here in the contract. So we can just pass this one, and we will need also to send the ETH, right? Because if we don't send the ETH, we won't get the 6 tokens. We just need 15 ETH. So we'll do value, and this is going to be NFT price. We're just going to send 15 ETH. And if you remember, we're going to receive this ETH back because of the vulnerability, because of this one. We are going to be the owners, and we're going to receive the ETH back. Now, guys, we have to pay back to Uniswap the ETH that we borrowed through the flash swap plus the commission, the 0.3% commission. So we need to calculate how much we need to pay back. So I'll do UN256 amount to pay back. And it will be basically just the NFT price multiplied by 103 divided by 100. So we are basically increasing it by 0.3%, right? So we're just adding 0.3% to this 15th ETH. And now, guys, we need to pay wrapped ETH, not native ETH. So we'll need to deposit it to the wrapped ETH contract. So wrapped ETH dot deposit, and we're just gonna send here the value. Value is the amount. And now that we have wrapped ETH, we can just transfer it, wrapped ETH dot transfer to the address of the per contract, and the value is just going to be the amount to pay back. So we make the per contract happy. We're paying the 15 ETH back plus this 0.3% commission. And now we suppose both to have also the NFTs in this smart contract, right? So we want to make sure to send them directly to the recovery address, okay? And let's see how the recovery works. So once we send them to the recovery address, this callback will be executed with a token ID and data. It makes sure that we are the origin. The player is the one who gets the NFTs. It makes sure that it got 5 NFTs, right? If it didn't if it token ID that is greater than 5, it will revert because something is off. It makes sure it receives 6 NFTs, then it decodes the recipient with the data. So we need to encode the recipient into the data, and it sends the recipient the price. So we need to encode the player account into the data, so we make sure that basically we receive the prize, right? The bounty. So let's prepare the data bytes. The data we are going to encode with this kind of transfer. So let's prepare it bytes memory, and we will call it data. And it's just going to be abi.encode with the player account, because the data should be just the player account, the account that will receive the bounty. And we will set a new for loop, uint256i, and I lower than tokens.length and I++. We're going to iterate through all the tokens that we just received from the marketplace. And for some reason, I just forgot to copy the comment over here. So I will copy this comment. Send NFTs to recovery contract so we can get the bounty, right? So now we iterate every single token, and we're just gonna use the NFT.save transfer form. We have to use the save transfer form in order to trigger this callback. If we just use the transfer form, it will not work, because save transfer form makes sure that it triggers this callback. From who are we sending it from? Address this. From this smart contract to the recovery address, recovery, what's the address? Recovery contract. Yeah, this one. Token ID is just going to be the I and the data, right? So we're going to just pass the tokens one by one, until this contract will receive all the tokens. It will decode the data and send our player account the ETH. This is beautiful. And now it's time, guys, to deploy our malicious contract and initiate the attack. So const free rider attacker, and let's do await ethers.get contract factory. The contract name is attack free rider, and we're going to deploy it from the player account, obviously, right? So const, and now we do this dot free. Let's just call it attacker contract equals await free rider attacker dot deploy. We're gonna deploy the contract with all the parameters that we defined in the constructor, which is pair, then marketplace. So where is the pair? Just Uniswap pair, then marketplace. So let's send Uniswap pair dot address, then marketplace dot address. Then wrapped ETH, NFT, and recovery contract. So let's see where we have it over here. Wrapped ETH token is the NFT. No, where is the NFT? So wrapped ETH, NFT, and devs contract. Wrapped ETH, NFT, and devs contract. So wrapped ETH.address, NFT.address, and dev contract.address. We just need to make sure that it's the right order, or we will get screwed. So pair marketplace wrapped ETH NFT recovery contract. Pair marketplace wrapped ETH NFT recovery contract. Perfect. Awesome. And don't forget, guys, we need also to send some ETH, but we'll do it in the attack function, right? So we'll do here something like await this dot attacker contract dot attack, and here we will have to send some ETH. So here we'll have to send some ETH because the 15 ETH is not enough. We need to pay it plus 0.3%. So let's open calculator and we'll do 15 multiplied by 103. 15 multiplied by 103 divided by 100. So we need 0.45 ETH. We need to pass 0.45 ETH in order to pay back to the Uniswap smart contract. So I will do ethers dot utils dot parse ether, and here we're gonna just do 0.45 ETH. Sorry, we need 0.045 ETH, right? Guys, we made a mistake. We need actually 0.3% and not 3%. And our calculation here is 3%. So it's supposed to be 1003 divided by 1000. This is the right calculation, right? Because we need to pay 0.3%. We don't want to pay too much to the Paris smart contract. And now we can do the same calculation. So it will be 15 multiplied by 1003 divided by 1000, and this is the amount that we need to send, 0.045 ETH and not 0.45. So this is the right amount that should be enough to pay back for the flash loan. And now guys, it's the money time. It's time to test our exploits and see if it works. So I'm gonna head over to the terminal and I'm gonna do yarn and free rider. Let's see, cross your fingers. Now we have another issue here. Since it's rounds it down, basically zero, if we do exactly 1003, it's not gonna work because it's gonna round it down. It's gonna be a bit less than what Uniswap expects. So if you see what happens, if I do 103, we get an error message, Uniswap K, which basically means that we didn't pay back enough tokens to the pair contract and we broke the constant value, the K. So what I'm gonna do is I'm just gonna increase it to 1004, and this should be enough. Let's see if this is actually gonna work. And it worked, guys. We were able to exploit the marketplace, give the NFTs back to the devs and get our 45 beautiful ETH bounty. This was amazing exercise. I hope you guys enjoyed it, and if you did, please subscribe to the channel and smash that like button. Thank you so much. Check out the other videos, the other walkthroughs of Damn Vulnerable DeFi, Ethernet coming soon as well. Thank you so much. I will see you in the next one. Bye bye.